Hello and welcome to the latest How to Code a Game Like Minecraft in Unity video. This one is, I think, part 26. And in this one we're going to cover non-cube shaped blocks. Or rather, I'm going to cover one non-cube shaped block, but the video will show you how to do non-cube shaped blocks, and then you'll be able to do whatever shapes you want. The reason I'm saying this is because the actual process of inputting the values for non-cube shaped blocks is long and tedious. And I'm going to kind of go through one of them with you on the video, but I am not doing it for all of them. So I'm going to do one block in the video. The process is easy, it's just tedious, and nobody wants to watch me entering numbers into text fields for half an hour straight. So please pay attention to the video. My new thing now is threatening to beat people with an inflatable banana for asking me questions that would be answered in the video. So yeah, pay attention to the video, because like if you want to do stairs at the end of this, or torches would be another thing that you'd be able to do with this. Well, the shape of the torches, not necessarily the light of the torches. Anything like that, you need to understand how this works. It won't be enough for you to just copy what I do in the video. You need to understand what we're doing in the video. So we will get started. So the first thing we're going to need is a new script, a new data class, sorry, which we're going to call voxel mesh data. I've put that in the data scripts data folder if you didn't see that. And we'll just immediately get rid of this because this is going to be a serializable class. And we don't need monobehavior, because it is going to be a scriptable object. But before we get into that class, basically this class is just going to be populated with other classes. So let's make those other classes first. And the main one we're going to call, well, is also system serializable. So let's just copy this, because as always, my typing is terrible, or at least it is when I'm recording. So this class is going to be called, it's going to be public. It's going to be called vert data, and this is going to hold all the information that we need for any particular vertex. At the minute, the only information that we need for any particular vertex is the position and a UV coordinate. We also need a normal, but we're going to be storing the normal somewhere else. You'll see why in a minute. So first off, let's get those two variables. Public vector3 position, public vector2 UV. We'll put a constructor in. I'm not going to be using it in this video, but you may need it. It depends how you decide to input your data for your block types. Because like I said, I'm only going to do the one block type, but presumably you're going to want more than one block type in your game. I'm just doing enough to be able to show you how to do the thing. But once you know how to do the thing, you can go use that thing to make as many things as you want. Then the next class we're going to need is also system serializable. And again, the system serializable will depend on, I need it for what I'm going to do, because I'm going to have it as a scriptable object. So it needs to be serializable so it shows up in the inspector. It's entirely up to you if you want to have it in the inspector the way that I'm going to do it. You could also store it in a text file the similar way that we do the block types, or in a binary file the way that we do save games, or you could enter it in code. It's like there's different ways you could do it. I'm not going to tell you that any of them are better than the other. It's entirely up to you. At this point in this tutorial series, basically, I think we've reached a stage now where I hopefully don't have to explain everything all the way down to the minutest detail. Hopefully I can get away with just showing you the method and you can fill in some of the details yourself. So public string direction. So this one is just a string. It's another way of saying name. Because this is a face, it's going to be facing in one direction. So it could be the top face, it'll be facing upwards, it could be the bottom face, it's facing downwards. This string is purely to make things easier to see in the inspector. So again, if you're not using the inspector method, if you're going to do it through a different means, then you probably don't need this. But I'm putting it in there just so that we've got a clear way of seeing which face we're dealing with in the inspector. This is the normal for this face, so that's why we didn't store one in the vert data, because there could be, well, for a standard block, each face has 4 verts, so that would be 4 normals as well, but all the normals for that face are all the same, so there's no point in storing 4 normals in the vert data when we can just store one in the face data. The vert data is going to be an array. So that's our face mesh data class. So as you can see, we have our vert data class here, and then we have an array of vert datas in here, and then the triangles. So if you haven't already guessed how this is going to go, basically we are going to store all of the vector 3 positions of each vertices, all the UV coordinates for those vertices, like localized or normalized or whatever you want to call it. And then when we go to draw a chunk, instead of calculating the positions like we're doing at the moment, we're just going to grab the voxel mesh data from this class and put it straight into the mesh. So it's actually going to simplify our chunk code quite a bit, or at least that part of the chunk code. So now we can go back up here and we can deal with this. You know, we don't need system serializable, so let's just get rid of that. But what we do need is create asset menu. I'm just going to call it new voxel mesh data, and then a menu name, which I believe we are storing our custom scriptable objects in Minecraft tutorial, which is not a big deal to change if I've got that wrong. And then in the class, we want a public string block name. Once again, that's just for our benefit. And then a public face mesh data. This is going to be an array. Faces. Now, this array here is going to be, all the faces. This is only ever going to be 6, no matter what type of shape you have. This is only ever going to be 6 because there's only 6 faces in a block. And even though the blocks themselves might not be cube shaped, it's still all going to work in those 6 faces. So if you think of stairs, there's 2 top faces. There's the top of the top stair and then the bottom stair. But those top faces are still facing up. So they count as one face in this system. And then obviously the bottom face is just one square altogether, like a normal cube. That also counts as one face. So this is always going to be 6, this array, and it's going to be in the same order that we do everything else in. So if I pull up our voxel data class down here, we have our order that we always do things in. So back, front, top, bottom, left, right. We're going to be putting the faces into our voxel mesh data class in the same order. And then that way we can use the same loops as always to access the right data for a given face. Let's save that, go back into Unity. I'll go into our data folder and I'm going to create a new folder, which we're going to call voxel meshes. And then if we go to create, we should hopefully have one in here. There we go, voxel mesh data. So I'm just going to call this one standard block. Just make this a little bit wider so it's just a little bit easier to see. So block name is just going to be standard block. And remember, this is block shapes. So it doesn't matter what kind of block it is. It doesn't matter whether it's transparent, whether it's solid, whether it has this texture, that texture. None of that matters for this. This is purely the shape. So we're just going to call it standard block. We need 6 faces, as I mentioned. And those faces we'll name now so that we've got them labeled. Back, front, top, bottom, left, and then right. Right, so this is where we get to the part that is going to be tedious to watch. So I'll just collapse all these. And we'll just focus on back for a second. So our normal for back is going to be -1 on the z-axis, because z is front to back, and so -1 is going backwards. So that's the normal for all of the verts in the back face. So regarding those verts, we have 4 of them. I'll just open these up. So the position, the first one is going to be 0, 0, 0. So that's the bottom left back corner. And then the UV is also going to be 0, 0. It's the bottom left corner of the texture that we're going to be looking at. The next one is going to be 0 again, but then 1 on the y-axis and then 0 on the z-axis. And the reason for that is you know what, let me just pull up trusty old paint here. So here is my amazing cube. So our first element 0 was here. That's 0, 0, 0. And then the UV coordinate, so if you imagine the vert is the 3D space. There we go. Should have been an art major. So the vert is 3D space. That's 0, 0, 0. But then the UV space is just the 2D space there. So it's 0, 0. So this is 2D. This is 3D. What a mess. So with that in mind, this here is 0, 1, 0, and then the UV coordinate is also 0, 1, but obviously there's no Z now. This next one is 1, 1, 0, and the UV coordinates are 1 and 1 again. And then finally 1, 0, 0 and 1, 0. So that is the back face. We don't need to do anything with the Z coordinates because they're already in the right place. But basically, for the front, these would all be 1, and for the top face, then all the Y ones would be 1, and so on. Basically, you're given the position of them. So I'm going to fill out the rest of these details. I'm going to speed the video up while I do this because it's boring. But anyway, I'll get into it. Okay, so that's all the vert data in. Now we need our triangles. So for our triangles, this works, if you remember, the same way it's always worked, which is if this was our, get rid of these for a second. If this was our face and we've got a vert here, a vert here, a vert here, and a vert here, then our triangles are drawing from each of these in a clockwise order. So let's say we started at, let's just change color here. If we started here and we went up to this one and then down to this one and then back to there, then our triangles would be 0, 1, and then let's say this one is 2, then this one would be 3. So our first 3 triangle numbers would be 0, 1, 3. And then to do the other one, it would, maybe we'd start at 3 and we'd go up to 1 and then across to 2. So then it would be 3, 1, 2. Sorry about the terrible writing there. So 0, 1, 3, 3, 1, 2 would be the triangles for this face. Now, I've put all of these vertexes in basically the same order. So we have 3 faces that have the exact same triangles, and then the other 3 have the exact same reversed triangles because it has to be clockwise. So basically we want to draw the same triangles but the other way around to get the face mirrored. So for our triangles, we're going to need 6 of each. Again, this is just for a standard block. If you were doing something like stairs, there would be more triangles and more vertices. And then for back, we want 0, 1, 3, 3, 1, 2. And for front, it's almost the same, but basically we want 0, 3, 1, 1, 3, 2. So yeah, 0, 1, 3, 3, 1, 2, and then 0, 3, 1, 1, 3, 2. Those are the 2 orders of triangles that we need for a basic cube and for half slab as it turns out, but we'll get to that. So I'll just fill all those out. So that should be all we need to do there. So let's just go back into, no, let's not go back. Let's go into our scripts folder and find our world script, open that up, and then we want to go down to our block types and we need to give each block its voxel mesh type. So we'll do that. I'll just stick it here. Public voxel mesh data. And then if we go back into here, we should find we have a space here, or at least we would if we gave it a name. So I'm just going to call it mesh data. Let's try that again. So there we go. We've got our voxel mesh type here, and we've only got one mesh data class, so we can just do that. So I just need to give all of our current blocks our standard. So we just need to give them all a standard block type. And now we've done that, we can actually start implementing this in our code. So let's open up our chunk script and scroll all the way down to where we add stuff to our voxel, this one, update mesh data. And basically everything inside here, we're going to get rid of. Almost everything. Let's go from, you know what, actually, let's just get rid of everything inside this, this loop. So that starts there, I think. Yeah. So let's just get rid of all this. And we'll start again. As it turns out, the first thing we want to do is retype the first 2 lines that I've just deleted. So voxel state neighbor equals chunk data dot map x y z dot neighbors p. And then we want to say if neighbor does not equal null and neighbor dot properties dot render neighbor faces. So we're only drawing this face if the neighbor allows it. And then we're going to say float, we'll get the light level first, equals neighbor dot light as float. And then we're going to need to get a sort of a vert count, but the vert count is just for the current face that we're working on. So we'll declare it here, vert count equals 0. And now we can do our code for adding the vertices and everything. So for int I equals 0, I is less than voxel dot properties dot mesh data, it's a bit of a mouthful this, dot faces, and then we pass in the p index because we made everything in the same order that we're doing all the other things, so we can just use that same index to access the right one. Dot vert data dot length, and then I++. Then we're going to need this in again in a second, so I'm just going to copy this. And then the first thing we're going to do is vertices dot add pos plus, and then this is where that comes in. Only this time we're going to say I dot position. So that adds our vertices, and because we're looping through however many vert datas we've got, it will add them all. And then normals dot add, and then we want voxel dot, we can just go, let's just use this again. Vert data, no, we don't want vert data, we just want faces, normal, and remember it's the same normal for every vert data, so we don't need to pass in the individual vert number index that we're looking at. Colors dot add, for now that's all the same, we're not changing anything about this, so we just want 0, 0, 0 light level. And then finally we want to increment our base vert count. So we'll do our opacity check to see whether we're adding this to our normal mesh or our transparent mesh. So if properties.render neighbor faces, and remember this one up here is checking our neighbor to see if our neighbor is transparent or if our neighbor is letting light through. This one is checking the voxel that we're actually drawing to know whether it's adding the voxel to the transparent mesh or the regular mesh. So if voxel.properties.render neighbor faces, and then all we do inside is for int I equals 0, I is less than, I'll paste that again, faces p.triangles.length, and then I++ obviously. And then inside here, all we're going to do is triangles.add vertex index plus, and then all this again, triangles I. So we're incrementing through each triangle and adding it to the list. And then we'll just copy this for down here, only this time we're adding it to the transparent triangles. And then under here, we want to increment vertex index by the amount of vertices that we've added. So now we just need to sort out our texture function to take into account the new texture system. So this is not that big a deal, to be honest. So first off, we don't need any of this. We'll get rid of that now. We've already done most of the work here. All we need to do is factor in our new UV values, which are just the values of the texture itself. So 0.5 will be halfway along whichever texture we are looking at. So let's start with that. X plus equals voxel data dot normalized block texture times, and then we need the value, so we're just going to bring in a second value here, vector2, we'll just call it UV, and then it's going to times UV dot X, and then Y plus equals, and exactly the same, UV dot Y. And then instead of adding 4, we're just going to be adding 1 because we're going to be calling this one each time. New vector2 xy, and then back up here in here we'll just stick it underneath color here. We can just type add texture. We'll probably need to rename that for naming convention's sake because it's not adding a texture anymore, it's adding just a single UV, but for now I'll leave it. Voxel dot properties dot get texture ID, and then the face index that we're currently looking at, and then we want, I'll just copy this again, all that dot UV. So let's just try running that. We should find that absolutely nothing has changed. Okay, so something has changed. I've inputted something wrong with the bottom texture somehow. I'll take a look at that. Everything else looks fine texture wise, and also it's not drawing transparent textures correctly for some reason. So just let me take a quick look at that. That's the weird bottom texture part sorted. It was just, I'd just put a couple of numbers in wrong in here. So I will now just quickly try and figure out why it's not drawing transparency anymore. Okay, it was a silly mistake. If we just go back into my code, it was here. There should have been an exclamation mark. and I didn't put one there. So yeah, that's why it wasn't drawing transparency like it should have done. So as you can see, everything is exactly the same, but now we are using the new system. So let's use our new system to create half-slab blocks. So we'll just duplicate this and we'll rename it half-slab block. And then in here, we shall also rename it half-slab block. Now, I've picked this block because it's the easiest one to create, given that we already have a full block. So if you think about a half-slab block, it is exactly the same as a regular block, but squashed down. So all the Z and X values are identical. We don't need to change any Z and X values. And basically, any Y value that is not 0 needs making to 0.5. So if we look on our back face, we've got 0, 0. We don't need to do anything there. Here, 0.5, and here 0.5. And then basically I want to do that for all the faces that have a Y value that is, well, they're all set to either 1 or 0. So any one that is set to 1 needs changing to 0.5. So I will just do that. Okay, so now if we go to our world and we will pick a block, I'm going to go with cobblestone. Obviously you would create a new block if you were doing this properly. I'm just picking cobblestone because I'm just demonstrating. But yeah, you would create a whole new block for just half slabs, and there'd be a half slab wood block and a half slab cobblestone block and whatever. I'm just going to change the current cobblestone one to a half slab one. Let's just run that and see if it works. So there you go, we've got a half slab. Now, if you are looking closely, you can probably already see that there is some problems with this half slab, which the main one being that the texture on the sides is all squashed. And then also, if we put one down next to a wall, you can see it doesn't draw the sides anymore. And that's because, as far as the game is concerned, this is a full block. And if you've played Minecraft, you'll know that it kind of treats it like a full block as well. So we need to fix that. Unfortunately, that's not that big a deal. Because we have arranged our code for the block mesh data as we have, all we need to do is go back through all these here and do the same thing we did to the verts with the UV coordinates. So we're telling it to only draw half a block, so we only want it to draw half of a texture. Right now it's trying to squeeze the full size texture into the whole block. Sorry, we don't want to change the bottom one because the bottom one is the bottom and top one don't want changing, because the bottom and top one are the same as they were before. And then as far as the transparency goes, if we go to world and we just tell our cobblestone block to now render faces as though it was a transparent block, and let's run that and see what happens. So first test, hey, our textures are no longer stretched. And second test, and we're no longer not drawing the sides. And yeah, so there's things to, there's fine tweaking to do. Like if I put a block here, I think in Minecraft, if you put a half slab on top of a half slab, it becomes a full block. I mean, you do that check when you put the block down. It's not difficult. I'm trying not to do everything in this tutorial series. So yeah, that's going to be where this one ends. Oh, right. Sorry. Yeah. One thing that I do need to cover right now, as far as the player controller is considered, this is a full block. So you can't walk up it like you could with a normal block. So I'm not fixing that in this one because we do have we have got to do a video on the player controller where we're going to basically rewrite it. I was going to say we'll fix some bugs with the player controller. We're basically going to start over with the player controller and do it completely over. So one of the reasons that I haven't done that already is because I wanted to have things like half slab blocks in place when I do, because obviously it needs to be able to navigate this kind of thing. And it would be hard to code that if we don't have any half slab blocks to test it on. So yeah, we're going to handle that in the player controller video, which is why it still treats these like a full block. So if you jump on it, you're going to be hovering in the air like so. But yeah, that is the end of the video. All that is left to do now is to thank my amazing Patreons, as always. And yeah, as always, massive thanks to anyone who likes, subscribe, watches the videos, all that kind of thing. Extra special thanks to the people who are on the Patreon, and extra special thanks to the people who are on the top tier on the Patreon, who get a special spoken thank you at the end of the video, like this. Thank you Dave Maldine, Michael Gulak, Reg Reed, Gabriel White, Julio Montero, and Professor DJ. So I will be out very soon with a video about the recent game jam I entered and won. And then it should be back to business as normal after that. So thank you everybody for watching, and I will catch you next time. Bye bye.